Now, again, we have some similarities between two different other non-visual senses. The first one is taste, and the other is smell. Now, again, interestingly enough, they are built off of very similar processes, a little bit like vision and audition are. They are built off of chemical compounds and registering them to produce what we refer to as taste or smell. So taste itself is a chemical sense, and it is a composite of sweet, sour, salty, bitter, and umami sensations, and of aromas that interact with information from the taste buds themselves. So most of the time we're familiar with the four: sweet, sour, salty, and bitter. We're not as familiar with the next one, which is umami. And if you've ever heard the phrase a chicken flavor, it tastes like chicken, actually there's some validity to that. It has the same significant taste, and it's been consistently identified to such a degree that it's actually been added to the four that we're most familiar with: sweet, sour, salty, and bitter. But these are all chemical senses. We taste, the taste buds are on the top and sides of the tongue. They have taste receptor cells that register each of these specific tastes, and then we make that information. That information then is processed in the brain, and it's very similar. The hair cells in hearing are very similar in function to the taste buds on our tongue. They take the chemical compound, they register it, and then send the signal onto the brain for processing. The other thing that's part of this, and this connects up with some of what we talked about with perceptual set, and the psychological component of taste, is expectations. And that is that expectations can have a huge impact. Expectations can also have a huge impact on taste. What we expect to find, how we expect to taste it, is actually part of how we see things. So you walk in and you smell something. Here's the olfactory nerves operating, again chemical. But there's no identifiable sensations, and because of how that is registered, it then triggers top-down processing. I smell something, and then I make some judgments about what it is, and then it also influences my taste of it as well. So olfaction, which is the term that we use for smelling, doesn't have any, it has no basic sensations, unlike taste does. And what you see here is how that whole thing operates, because the chemical compounds, which is in air with odorant molecules, get registered in the olfactory receptor cells. Then it triggers this olfactory bulb, which is in your nose, to then send signals via the converged axons onto the brain itself. We have 5 million or more olfactory receptor cells, and they have approximately 350 different receptor proteins that they can recognize that as part of the odor molecules, with some odors triggering a combination of these receptors. So 5 million receptor cells, about 350 different receptor proteins that can be registered, which is part of receptor proteins, which is part of just registering a smell at all. And so, you know, if you, for example, have a very nasty smell and you open your mouth to breathe through your mouth, you are taking in those chemicals through your tongue instead. It doesn't register the same way, but it's a good example of this. And they send information through then to the brain through the olfactory bulb that goes then into the brain to be registered.